Namaste, welcome back to the Pragna channel. You are watching AWS Cloud Projects for Beginner to Expert. We Our last project was supposed to be the last one, but CloudQuest added two more projects, and this is one of them. And this is going to be about text to image creation using generative AI. And we already know since the Chat GPT and I think Gemini. I don't know what's the AI for Amazon. Not sure. Since all these new AIs are like all over the internet, I guess they thought of like let's make a project with that technology on CloudQuest as well. So here we are. So this project is going to be about text to image creation using generative AI. And as I'm recording this, I just read an article wherein the Google Gemini was having issues with rendering images whenever users ask, right? Like historical figures and all. It is showing images in a not inappropriately, but it's generating images with wrong skin color and etc. So that is being an issue. So they shut it down. So let's see when that will be up. Good morning. As you know, we at Island AI Solutions are eager to enhance our generative AI capabilities. Our main challenge is incorporating our unique image collection into a generative AI model. We need a solution that can efficiently handle this. Yes, I understand the importance of tailoring a large language model to fit your specific needs. Exactly. For us, it's vital that the model learn from our dataset and is also scalable and maintainable. Can SageMaker handle this? SageMaker is equipped to host a variety of foundation models, which can be progressively trained and customized using your specific dataset. SageMaker is designed for scalability, providing a seamless adjustment of resources in response to the changing needs and demands of your projects. That's reassuring. Now we need a prototype that demonstrates how this can be effectively done. Absolutely. That's a great approach. We can start by using generative AI to create a visual summary. This will help your team understand the process and identify any potential challenges early on. That sounds promising, but how will we incorporate our specific image data set into this prototype? We will use SageMaker to retrain the foundation model with your dataset. This means that we will integrate your images into the learning process, tailoring the model to better fit your company's unique needs. Great. However, we lack the in-house expertise to develop such a complex prototype. Will you help us build it? Sure, I can help you. To start, I will need access to your image dataset and any specific requirements or goals you have for the model. Plus, regular check-ins will be important for feedback and adjustments. Great, I will arrange for you to get the data and we'll set up a weekly meeting schedule. We are looking forward to seeing how this prototype develops. Can you show us how to generate images from text using generative AI? Of course, I will. Thanks for helping us. So we are going to deploy LLM on SageMaker endpoint, which we have done, I think, in first few projects. And then we'll fine tune an LLM by using image datasets, which we have done as well. Deploy the fine tuned model. Yes, we have done similar projects. All right, let's look at the video concepts. And we have covered all these video concepts. But if you haven't watched, go ahead and watch them. I highly recommend this. These can be watched from the playlist that will pop here. Click on it, go search with these titles, then watch all the videos and then come back. If you already watched most of this, check if you watched generative AI overview or not. Once you watch that, come back to the project and watch the remaining part of this video. This solution integrates generative AI to create visual summaries from text prompts. It also includes training a large language model with specialized image datasets to enhance image generation accuracy. Generative AI models such as Stable Diffusion can transform text into detailed images, combining deep learning with context analysis for precise visual creation. The SageMaker Python SDK offers algorithms and pre-trained models for quick deployment, either directly or after fine-tuning on custom data. The SDK also allows model access using IDs and versions. Through a SageMaker Studio notebook, the necessary libraries and tools are imported. Through the SageMaker SDK, a pre-trained text-to-image LLM is deployed to a SageMaker endpoint. Basic testing is conducted in the notebook by making API calls to this endpoint for inference. For enhanced accuracy with private images, the LLM can be fine-tuned on SageMaker. This involves estimator setup, training path and instance type configuration, algorithm hyperparameter adjustment, and automated hyperparameter optimization. We have not done this automated way. We have adjusted hyperparameter, and we have also set up the estimator, training path, and instance type configuration previously. The model, when fine-tuned and configured, is deployed to SageMaker endpoint. This endpoint acts as the access point for the model, handling prediction requests. All model artifacts are stored in S3 bucket. An AWS Lambda function is written to interface with the SageMaker endpoint. This function handles the input and output formats and serves as a bridge between API gateway and model provisioning, a streamlined process, which we have done this particular setup as well. API gateway is configured to create a RESTful API for the Lambda function. This step exposes the model's functionality to external applications and allows secure and managed access to the model. Web application is deployed, which we have done, and CloudFront distribution is established. We have done that as well. Calls to API gateway are embedded within the application's code, connecting the user interface with the underlying Lambda function and SageMaker endpoint. So pretty much that's about it. So let's go ahead and see what we are going to do as part of the practice lab. We'll use Jupyter Notebook in SageMaker to import the required code base, prepare a large language model to deploy in SageMaker, deploy this model to endpoint, then integrate the endpoint into practical application using CloudFront S3 API and Lambda. As part of DIY, we will use another notebook to fine-tune the LLM by using image datasets. Then we'll deploy the fine-tuned model, then we'll update the Lambda code to use the new SageMaker endpoint. Okay, so let's go ahead and implement this project. Let's start the lab. There aren't any files. Most probably they are in S3. Let's click next. Let's go to S3. Open the. We have done this drill. We will copy the URI of the. Oh, they have the notebook. That's fine. We will copy the bucket name and then we will import all these files into SageMaker. So let's go to SageMaker, which is already running. This is the Studio Classic, or you can also call it as Jupyter Lab. And we go to terminal. We will install if unzip is not installed. Then we will copy all the files from that bucket into here. And as you can see, we have both the notebooks and the training data images, I guess, thousands of images. Then let's open the generative AI notebook and let's use M5X large for this one. Then let's select it and then we will go through the steps that are displayed on the notebook. Usually it will be installing the libraries required to run that model. And then we will set up the data, we'll clean up the data. These are images, so there is no cleanup required. And we are viewing, as you can see, advanced features. Be more about it. Oh. Where are the hands? Yeah, that's what I thought. Why does the horse look like this? Okay, once that is done, let's go to SageMaker. Let's scroll down and we can see the endpoints. And okay, they are asking us to copy the endpoint. I guess we will paste this in the Lambda environment variables. Yep, see, we go and paste it. And bucket name, is that the bucket name? Yeah, I guess so. They already have that. And this is endpoint test function. Okay, what is this? Start to process function? What is that? Okay, so this is the one that will be triggered by API gateway. Okay, but what does this do? The code invokes endpoint test function. Okay, the other function that we just modified, this invokes that. Okay, and then get image function. Yeah, uses the payload to invoke the lambda function. Okay, The code fetches the latest image from the S3 bucket. It returns the response to API gateway. Latest image? What image? The LLM's image? API gateway, post, click the, copy the URL. Then let's go to CloudFront distribution. We have done this previously. Copy this URL. There is a web app that is running. Yeah, they will ask for the API URL. Then the prompt. What are we pasting here? Um, Pressing generate invokes an HTTP post request to the API using the prompt text areas payload. Okay, and what are we? Okay, what is it saying? The action. Where is the action? The action prompts API gateway to call start process function. A timer for 1 minute begins in the application. After the timer ends, an HTTP GET request is made to the API. API gateway then calls get image function. Finally, the application displays images in the output section. Oh, okay. Once it runs, it will again get it. That's why we have so many functions. Okay. Then what are we typing? Alien on a horse. And we are entering 768 by 768. Then generate it. Okay. Maybe we can come up with some cool prompts. Alien on a horse. Who wants to see alien on a horse? Sure. Why not? That looks very accurate. Okay, then if you go to the S3 on the generated images, you can review them. Okay, I think pretty much that's it. The lab is still running. So let's see how once that is done, let's train that model, then deploy it, then execute it using Lambda API and CloudFront. Let me pause this and I will be back once the lab is started. All right, our lab is ready. Let's open S3. Let's copy the bucket name. I think that should do it. Now let's go to SageMaker for the 15th time or 16th time maybe. You can click on this and launch Studio, or you can just click on the Studio on the left. Okay, we are here. Let's click on our Studio Classic, private, open. All right, now let's go to File, New, Terminal. Okay, let's copy the files. AWS S3 copy S3 colon. Let's paste the bucket name and everything. Or what? There is nothing in it or what? Oh, sorry. Okay. Hold on a minute. Let's go. Not there. Okay, we have files. Okay, let's see. Oops, maybe here. Maybe here. AWS S3 copy paste. Yeah. All right, now let's bring, we cannot use copy. Copy is for objects. Now we need the complete bucket. Let's see, do I have the bucket name here? Copied, yeah. So let's sync it. Sync actually brings in everything to here. That's it. And if you click here, you should be able to see them. And oops, yeah, I think anyways, we need this one. Let's open it. Let's click. I think this is what they selected. In this notebook, the SageMaker Python SDK is used for text-to-image tasks, generating realistic images from any text input through state-of-the-art pre-trained stable diffusion models. This notebook was tested. Okay, yeah, that's fine. To host on SageMaker, we must first set up and authenticate the use of AWS services. Here we use the execution role associated with the current notebook as the AWS account role with SageMaker. That's fine. So that's why we are getting it. And we are getting the region from this session, and we are calling the S3 client, and then we are getting the bucket name, and then we are setting that as the default bucket for this particular session. A complete list of SageMaker pre-trained models can also be accessed at here. Okay, these are all pre-trained models, pre-trained SageMaker models you can use. Okay, so here we are defining two variables with model ID and its version, and its name is model text to image stability AI stable diffusion version 2. Using SageMaker, we can perform inference on the pre-trained model even without fine-tuning it first on a new dataset. We start by retrieving deploy image URI, deploy source URI, and model URI for the pre-trained model. To host the pre-trained model, we create an instance sagemaker.model.model and deploy it. This might take a few minutes. Okay, so basically we are getting the image ID, and then we are, you can see that retrieving the image. Then image retrieve all those, retrieve the inference script URI, retrieve the model URI. What are we retrieving here? Docker container URI, inference script URI, they are already pre-made and stored. Model URI, and then maximum response size for endpoint. Okay, this is ready, so let me go ahead and trigger this. Okay, that is done. Let's create the run this. Done. Let's run this one now. Okay, and here we are creating the SageMaker model instance, and then finally we are deploying it. So pretty much in one cell we are doing everything. Okay, this is going to take obviously some time. So once we do that, we will query the endpoint and we'll parse the response. Input to the endpoint is any string of text dumped in JSON. So what are we trying to get out of here? Let's see, where is it? Okay, display hallucinated image. Okay, that's what we are trying to do. Okay, let this run first. Then it will test. Next, we will put in some example input text. You can put in any text and model predicts the image corresponding to that text. Cottage in impressionist style. But what are we doing here? It's a function. We are encoded text. We are preparing how the response should look like. Okay. Parse response. Then we are pausing it. The query response. The query response is coming from where? Okay, we'll see. Dictionary JSON, and then return generated. Okay, we are returning two dictionaries. Then we have another. Okay, we are just creating functions. We are not doing much here. Okay, so these functions, I guess they will use them here. Okay, once you have the text, then you have the query response. So you are using the query function right here where it will take model predictor, which is created here, and then the text, this one. Then it will spit out the output, and that output I am assuming is sent to parse response to parse it in a certain way, as you can see as two dictionaries, display image, and then you are passing these two dictionaries to this particular function. Then it is plotting it. I think it will show it to us. Advanced features, we'll read through that. Let this finish. Once this finish, I'll come back, then we can continue. All right, it is done after some time. So let's go ahead and create these functions. This should finish very quickly. Now let's go ahead and actually run it. It should be quick as well. Once the model is trained and deployed, it should not take that long. At least usually it doesn't take that long. Okay, it doesn't. And as you can see, this is the image that the AI generated when we asked it to draw cottage in impressionist style. Okay. This model supports many advanced parameters while performing inference. Those include prompt, the guide for image generation, which is the text that we gave, width, height, width and height. Number of inference steps, the number of denoising steps during image generation. More steps lead to a higher quality image. If specified, it must be a positive number. Guidance scale, higher guidance scale results in an image closely related to the prompt at the expense of image quality. If specified, it must be a float number. Negative prompt, guide image generation against this prompt. If specified, it must be a string or a list of strings and used with guidance scale. If guidance scale is disabled, this is also disabled. Moreover, if prompt is a list of strings, the native prompt must be also a list of strings. Number of num images per prompt, the number of images returned per prompt. If specified, it must be a positive integer. Seed, fix the randomized state for reproducibility. If specified, it must be an integer. All right, let's go ahead and run this. What does this exactly do? Payload, we are giving astronaut on a horse, and we are creating isn't it the same thing that we did it there, those functions? I don't know why they are creating it again. And for image in generated images, display image and prompt. Okay, so it is going to display those for us. But why did they? Okay, maybe they use this payload. Maybe that's why. Oh, this is more, yeah, this is better than the one that they got. This looks, at least the horse looks nice. Astronaut on a horse. I don't know why anybody would want that, but anyways, here we are. Just went through, where is it? The practice lab. Let's do the DIY. Now let's go ahead and run the second Python notebook. Okay, and deploy the fine-tuned model to a SageMaker endpoint, update the Lambda code to use the new. I think they didn't tell much here for us to do. So let's go ahead. Where is this thing? Okay, here we are. So let's open that. And I think let's use the same thing, which is going to take some time. So it's going to be the same as usual by using this model. In the DIY notebook, you learn how to fine-tune the stable diffusion model for your dataset. Previously in this notebook, we have seen how to use the stable diffusion model as is, but here, I mean, that is created by some other company, right? They trained it using different kind of data set that might be same or different to whatever your company wants to train. So obviously you can use it, but it won't give you accurate results that you are expecting because it is trained on a different data set. So what we usually do is we fine tune it, and it's also called, I guess, what is the term that said, transfer, model transfer or something. I might be wrong, correct me in the comments. What we do is we use that model the foundational model, and then we train it using our data set. So this can be useful when creating art, logos, custom designs, NFTs, or fun stuff such as generating custom AI images of your pets or avatars of yourself. All right, now let's go here. Before running this notebook, some initial steps are required. For this setup, this notebook requires IPY widgets and the latest version of SageMaker. So I guess that this takes care of it. This is installing matplotlib, and then again we are getting the region name, connecting to S3 and getting the bucket name as well. Wow, this already created it. Awesome. So let's go ahead and run this. This shouldn't take much long. I mean, it's installing this. Other than that, yeah, it is done. And previously we saw how to run inference on a pre-trained model. Next, you explore how a model can be fine-tuned to a custom dataset with any number of classes. The model can be fine-tuned to any dataset of images. It works very well even with as few as 5 training images. The fine-tuning script is built on the script from Dreambooth. You can go there, I guess. Abstract approach if you want to learn more about this particular model. Okay, so that's that. The model returned by fine-tuning can be further deployed for inference. The following instructions describe how the training data should be formatted. Input: a directory containing the instance images, dataset info.json, and optional directory, which is the class data dir. Images can be of PNG, JPG, or JPEG. The dataset info.info must be a format that, if with prior preservation equals to false, you can choose to ignore class prompt. The class data directory must have class images. If with prior preservation true and is not present or not enough images are already present in that directory, additional images will be sampled with class prompt. A trained model that can be deployed for inference. The S3 path should look like the S3 bucket slash input directory, then you should put a slash. Here is an example format of the training data. So we have the input directory, then the images, then the .json, and the class data and its images. Preservation, instance prompt, and class. Prior preservation is a technique that uses additional images of the same class that we are trying to train on. For instance, if a training data consists of images of a particular dog, with prior preservation, we incorporate class images of generic dogs. Prior preservation tries to avoid overfitting by showing images of different dogs while training for a particular dog. A tag indicating the specific dog present in the instance prompt is missing in the class prompt. For instance, the instance prompt might be a photo of a Doppler dog, and the class prompt might be a photo of a dog. You can enable prior preservation by setting the hyperparameter with prior preservation equals to true. We provide a default dataset of dog images. It consists of images of a single dog with no class images. If using the default dataset, try the prompt a photo of a Doppler dog while doing inference in the demo notebook. Here we retrieve the training Docker container, the training algorithm source, and the pre-trained base model. Note that the model version fetches the latest model star. So as you can see, we are defining 3 parameters. The model ID is model tx, which is something that we used previously, and even the version is the same. And the train scope is training, and we are going to use the instance type MLP3 to X large. And then we are retrieving the Docker image by specifying the model ID, which is from here, and the version from there, scope from there, instance, which is what we created. You use these parameters to retrieve the Docker image. Then train source URI, retrieve the training script, image URIs, script URIs, and then we are retrieving the pre-trained model similar to the last one. These 3 steps are similar to the last one. We are retrieving the model. But last one, after this, what did we do? We deployed it, right? After we got it, we deployed it, but here we are not going to do that. Now that we have finished the required setup, we are required to train our stable diffusion model. Previous one, we didn't train it. To begin, let's create a SageMaker estimator object. This estimator will launch the training job. Two sets of parameter need to be set for training. The first set includes the parameters for the training job, training data path, output path, instance type. This indicates the type of machine on which to run the training. We previously defined the training instance type to fetch the correct train image URI. The second set of parameters include algorithm specific training hyperparameters. So we are setting the bucket and the bucket's prefix and then the complete URL path, and then we are getting the default bucket from the session, and output prefix is going to be training, and we are preparing its. Okay, I didn't run this yet. Okay, that is weird. I don't know. I should have run it. It will take time now. Okay, no, it doesn't. And then let's create this, which will run quick. Even this. Okay. So here, for algorithm specific hyperparameters, we start by fetching the Python dictionary of training hyperparameters that the algorithm accepts with their default values. This can then be overridden to custom values. So hyperparameters dot retrieve defaults, we are getting model ID. For this model ID version, we are getting the hyperparameters, and then we are overwriting the max steps of that hyperparameters and we are printing them. So these are all the hyperparameters currently, and we overrode one of them. If setting with prior preservation true, here it is false by default. Use the MLG5 2x large instance type because more memory is required to generate class images. Currently training on the MLG4DN 2x large instance type runs into a CUDA out of memory issue when setting that one. Okay, we are not doing it, so that's fine. Amazon SageMaker automatic model tuning, also known as hyperparameter tuning, finds the best version of a model by running many training jobs on your dataset using the algorithm and ranges of hyperparameters that you specify. It then chooses the hyperparameter values that result in a model that performs the best. As measured by a metric that you choose, we use a hyperparameter tuner object to interact with SageMaker hyperparameter tuning APIs. Here we tune two parameters, learning rate and max steps. We have not done this so far in our last 15 projects. We defined our own hyperparameters. We didn't tune even the hyperparameters. This is a cool method, you know. The range, we give the ranges, then it runs bunch of times and then figures out what is the optimal hyperparameters that we should be using. That is awesome. We start by creating the estimator object with all the required assets. Then we launch the training job. The code run might take up to 15 minutes to be completed. Okay, that's fine. Training job name, we are defining it, and then remember estimator we created by giving the role, image URI, directory model, entry point, instance count, hyperparameters, and then the output path and base job name, and then let the estimator emit fit score metric to empty, not sure what that is, and then we are setting the compute, the hyperparameter compute feed equals to true, and tuner parameter, this is for the hyperparameter tuning, and that's what we are calling. And once we got the tuner, we are fitting that, uh, in other words we are training the model. So let's run that, and they said it is going to take 15 minutes, so we will be back. In the meantime, let's look at this. If you set max jobs equals to 9 and max parallel jobs equals to 3 above, that's what they are talking, it takes around 60 minutes on the default dataset when using automatic model tuning. Since we only picked one, it is not doing much. If more quota for the training instance type is available, increase the parallel jobs. A trained model, once that is trained, next step is what? Deploying it. A trained model does nothing on its own, obviously. We now want to use the model to perform inference. For this example, that means predicting the bounding boxes of an image. We follow the same steps as in run inference on the pre-trained model. From here, we start by retrieving the SageMaker jump shot artifact for deploying on endpoint. However, instead of base predictor, we deploy the OD estimator that was fine-tuned here. Even this will take 15 minutes. Okay, that's fine, we will wait. Once that is done, I will come and trigger this one. But as you can see, image URSs you have already seen from above, but above we brought in the base model, but here we are going to use, what did we name it here? Okay, let's see here, what are we passing? These are inference instance types and find predictor use amount, is that what? No. Okay, so where are we storing that? Instance count, instance deploy image URI, endpoint name, model name. It retrieve the inference Docker container URI, automatically inferred from model ID. Use the estimator from previous step. Yeah, where is, okay, yeah, here, SD estimator. Okay, yeah, here we go. Okay, this is what. Okay, so we are using the SD estimator and we are deploying it. Once you deploy it, we are testing it with some dummy data. What are we passing it? A photo of a Doppler dog with a hat. So once that is done, I will come and trigger this one as well. 50, 50, 30 minutes. So let's go get a coffee. And I just got reminded that we missed a big part of the practice lab, which is after executing this. I don't know if it is still up and running. I'm assuming this is. And I just got reminded that we still have to test the whole Lambda API integration, which I completely missed out. So let me go ahead and fix that while this is running. Anyways, this is almost done. We are training the model. Once the model is trained, we have to deploy it. And I think that will be done for even DIY. But let's go ahead and check that part out, right? So what does it need if I go to the Lambda, right? We need to go to the Lambda. And there are a couple of lambdas, but the only one we need to at least edit or modify it is endpoint test function. This one has a configuration with environment variable where I think that's the bucket name and the excuse me, endpoint name. We need the endpoint name. So let's go here, jobs, training. No, not here. Deployments, endpoints. Okay, so we have the endpoint. Let's click here. Wow, the endpoint name is that. So let's go ahead, edit it, replace it, save it. So pretty much that's that. And did they remind? Let's think about it. Okay, what does this do again? Endpoint test function, create and upload image. Okay, so this is going to invoke the endpoint, then get the image, then it will upload the image to S3. Okay, pretty much that's what it is doing. And we had other functions, get image function, start process function. I think this is what is triggered by the API gateway. Yeah, I don't think they asked us to create anything, did they? No, I don't think so. Okay, I cannot download all. Okay, so we have all that. Now let's go to the API gateway because we need to copy its URL. In the meantime, we can open CloudFront as well. Let me open there. So API, let's click on that. And you can see it is integrated to the Lambda function. And if you want to see which Lambda function, start process function. Let's go to stages, prod, generation, post. Let's copy that. And this is a cloud URL. If you click on that, this will, okay, let's copy it here. And let me paste it there. And you got that. Now let me go ahead and copy this one because it asks for the URL. So now using the first one, this is still running. The first one, what is the text we used? Astronaut on a horse. And what did we get? we got this one. So let's run it from here again and let's see what we are going to end up with. And this 768, it doesn't matter. Okay, so let's generate it. I mean, this is still up. Okay, this runs for a minute. At least that's what they said. So what does the okay? So this is CloudFront. We are hosting this static website on S3, and when you put this, what this app does, it is going to send the payload to the API, which is the post. Is it post? Yeah, post we did, and it sends prompt and image width and height. And this in turn is going to send that data and trigger the lambda, which is the start process function. It is going to trigger this. I don't know if it will do it in 1 minute. It will trigger this one. What is this going to do? This is going to invoke another function, which is the processing lambda name, which is the processing lambda name that is getting from the environment variables, which is the endpoint test function. Endpoint test function is going to trigger the our model, trained model. So let's see, is this the not here? Where is this? Oh no, is that the one? Oh no, I don't know what I'm doing. Okay, I closed all of them. Ah man. Okay, let me do that again. Come on. Okay, let me copy this again. I think we have to wait a minute again. That's okay. I don't know why I was hitting all close. Copy it, paste it. We can totally do 1920 by it will just take time and it's okay. That's fine. I don't want to do it. Okay, let's see what's going on with our DIY. Okay, this is done. We have trained it and let's deploy it. This is again going to take at least they are saying 15 minutes, but I don't know. We'll see. And let's come back here and this is going to run. Let's see. Let's give it some time. And if you go see the jobs, it will show you these are DIY, but the previous one it ran or not. This is 28. Okay, well, where are the jobs for the other one? I think this is the one. Is this the one? Oh yeah, these are the training jobs. The initial one we didn't train anything, so that's why. Okay, that makes sense. There are plenty of instances, huh? Flowers. I think this they started and this we started it. Two of them, right? Oh, for the second one, I didn't I pick this one? Hmm. Okay, this is done. Okay, not bad. Even the horse is looking good. Even the astronaut, if you compare that with this one, it's not definitely not the same horse, is it? Nah, it's not. Right? And even the astronaut is different. Okay, not bad. So yeah, now we tested it, which is good. And for the DIY, I don't think they're talking anything about doing all that. They are asking SageMaker endpoint name and SageMaker model name. I think this will print it somewhere. If not, let's see. Uh, it's not printing it. Endpoint name. Anything printing it? Nothing is printing it. Okay, so what we will do is we can go here, And let's click on endpoints. So this is getting created. This is our DIY. So let's copy that. And that's the endpoint name. SageMaker model name. Where can I get that from? I think somewhere here they might have created it. Model name. Okay, where is it? It has to be somewhere. Can I do a control F? Oh, here we go. Name from base. That's it. And we are getting it from, that's the endpoint. No, it can't be that. Okay, let's go here. Won't this show the model name somewhere? Yeah, here we go. Don't do this to me. Give me the model name here. Okay, can I get it from anywhere else? This is endpoint, endpoint. It's not letting me copy everything. See? Okay, what if I just use this name and add this to it? Oops. It's not. I'm just thinking, is this the only place I can get it? Oh, we have it here and I cannot copy it. I think looks same to me. Just let's add the 10-820, 10-820. Okay, I think that should be fine. So let's go ahead and see how this is faring. Okay, looks like it is done. And now let's go ahead and run our function, creating functions. And finally, let's test it. A photo of a Doppler dog with a hat. This is based on the trained model. Let's see how it looks. And we can go ahead and run it using the not trained model. And let's see how it is going to see. Trained model, not trained model. Oh, this is going to take time. Okay. This looks like a real image, a photo of a Doppler dog with a hat. Don't you think so? Now, this is the image based off of our trained model. And where is this? This is going to be based off of the foundational model. In the meantime, let's validate this. Let's submit this one. This should work for us. And as you know, if you're watching the previous, every time we do this, this is not doing it for us. And we are doing the same mistake every time. So it is indeed checking the lambda, which I will go change it after this is generated. The all lost 3 or 4. Okay, this, I mean, it's looking okay as well. If you ask me, it's generating a nice one as well. Anyways, so let's go ahead and update the endpoint name on the lambda function because this is using the lambda function to evaluate. So let's go. configuration, edit, save it. Yep. Every time we ran it so far, that's what this did. Okay, so before, okay, I think once I submit it, I think it might have closed this. Let me see. Did it? Okay, it didn't yet. So what I want to do is I want to go to S3, close all this, and lab. Okay. Now, if you want any of these files, send me an email. My email is in the profile of the YouTube channel. So now let's go. This is done. What is next? The quiz. And if you are watching the last 3, 4 projects, you know I'm doing horribly in these quizzes. I think other than the last one, I scored 2 out of 5. In the last one, I scored 3 out of 5. Let's see how much I'm going to score. I think you guys are winning over me by a large margin in all the previous ones. So let's see how I'm going to fare in this one. Am I going to get more than 3 or not? Let's see. Because these, I mean, at least in the last 3 or 4, we were using a particular service. And in this one, we didn't use any service other than SageMaker. So I don't even know if they're going to ask any questions. The reason being, we already answered so many quizzes that involved SageMaker. So in one of the quiz, they didn't ask any questions. I think they are out of all the questions for SageMaker. Let's see if they ask questions regarding SageMaker. You will see the quiz one more, and I will get this final batch. If they don't, then I will edit that part, and I guess that should be all, at least for this project. Let's see. Fingers crossed. Okay, they are asking which statement is true regarding the use of datasets for training models with SageMaker. Datasets larger than are not allowed. Datasets you can use have no size. Datasets you can use have a strict size limit. I never saw anything that says there should be a size limit because we are storing these on S3, and as you know, S3 doesn't have a size limit. So I will go with you can have no fixed size limit. Let's see. Okay, maybe here. I don't know if it will. Okay. Data supports various enabling you, so you can quickly transform, etc. If you are using larger, you can increase Wrangler size. I don't know, it's not talking anything about it, so I will just go with that. And I am correct. Wow, scored 1 out of 1. So let's go ahead. Okay, here we go. And this area was so buggy. If you remember, see this? This is what I'm talking about. This area is so buggy. It just went through it. Went through that. Okay, let me try to. This particular area is so buggy. I couldn't get to any bots in one of the video. Okay, this is fine. What are the capabilities of SageMaker Studio Classic, web-based integrated IDE for machine learning? To write code in Jupyter Notebook, prepare data, build and train models, deploy models, monitor. Oh, I mean, this has plenty of it, so I will just go with that. 2 out of 2. I hope you are getting the answers as well. Which statement best describes the deployment options provided by SageMaker to build and train models? SageMaker offers real-time inference, batch transform, asynchronous inference, each suitable for different workload requirements. Yeah, I think so because we were doing real-time inference, and I'm assuming it also provides this. Batch transform in SageMaker is primarily used for real time with large payloads. I don't think so. I don't know. I think I will go with this one. See, asynchronous inference, serverless. I don't know if they are talking. I will go with that. We'll see. 3 out of 3. I don't know what's going on today. SageMaker. I think I'm good at answering SageMaker questions. Did I miss that? What are the main features and capabilities of SageMaker inference? Picture has a lot of text. Let's read that first. Used to deploy machine learning models for making predictions, offering both endpoint-based inferences and batch inferences, and integrating with ML ops tools for effective modeling management. It's not that. I think it should be this one. 4 out of 4. I think all. I think my curse officially is broken. Oh, I'm not shooting. I just shot once. The final question. What is the significance of foundation models in the field of machine learning and artificial intelligence? They are large, deep learning neural networks trained on massive dataset used as a starting point by data scientists to develop ML models quickly. And oh, that's fantastic. All right, so I scored 5 out of 5. And do post my score along with your score in the comments. Let's see who won. And thank you very much for spending your time here. And have a great day. See you in the next video. Peace out.